Okay, boys, let's have a look at complementary relationships. Now, geez, they don't appear a real lot, but I guess we've got to talk about them. So, a complementary relationship, on our previous exercise, we spoke about how we always want to work from the horizontal axis. Okay, so that length there of sine theta is that length here, and that's going to be always pi plus or minus some angle. Okay, so it's always, sine plus or minus some angle is always equal to sine of the angle. We've just got to work out whether it's a positive or a negative, and we do the same for cosine. Now, it is possible, okay, but not likely, that that length there, if we have a look at that length there, well, that's the same as that length there, okay? And so if there's my angles here, well, here, that's the opposite side. Here, that's the opposite side, okay? There's still my adjacent side there. But if I want to reference that angle, it's this triangle here. I'll do it in blue. This triangle here that we're talking about. That angle there is pi on 2 minus theta. Now, I don't want to go into the theory too much. I guess all we want to think about is if I have sine, cos, or tan of pi plus or minus an angle, or sine of 2 pi plus or minus an angle. In other words, anywhere on the horizontal axis, it's always equal to sine of the same angle, but what changes is maybe the sign. You just got to work out which quadrant we're in, okay? If we're going to look at the vertical axis, so if I have sine of pi on 2 plus or minus an angle, or cos of pi on 2 plus or minus an angle, well, it becomes, so the sine, pi on 2 plus or minus, becomes cos of the angle, and a cos becomes sine. And again, all we've got to determine is what quadrant we're in and whether we should be positive or negative. Okay? So if we just have a look at these examples here, so sine of pi on 2 minus, I don't know, phi maybe. So sine of pi on 2, now that's just equal to cos of whatever that angle is. Now think about what quadrant we're in. Pi on 2 minus the angle, that's in the first quadrant, so everything is positive. So it's going to be a positive cos of phi, and that's 0.8. Obviously, because it's been given to us, okay? Cos pi on 2 plus theta. So cos of pi on 2 plus theta, now that's equal to sine of theta. Now let's think about pi on 2 plus theta is the second quadrant. Cos is negative there, so I should get a negative answer. So it needs to be a negative here, okay? And so then that'll be equal to sine of theta is negative 0.3. Sine of minus theta, well, that's just going back to our standard stuff. Minus theta, if that's theta, negative theta's down there, it's negative, which is equal to negative sine theta, which is negative 0.3. Okay, so you just got to remember, look, and we don't see it often, and I've tried to confirm whether it is or isn't in the course, but I can't, so we'll cover it. So it's just something to be aware of. All right, here's a little bit of solving, a little bit of revision. We'll certainly cover a little bit more of that. Find the values of theta between 0 and 360. So this is going back to our exact values again. Cos theta, so we identify which quadrants cos is positive in. It's positive there and there. There's my angle. Cos inverse of root 3 on 2. Cos of what angle is pi on 6. So then my solutions are theta is equal, pi on 6 is 30 degrees. So it's going to be obviously 30 degrees. There's 0 and all the way around to 330 degrees. Okay. Similar, I'm running out of room here, boys, so we'll come over here. whereabouts is sine negative? Sine is negative there and there. All right, so sine inverse of a half is equal to, well, that's 30 degrees as well. So my angles are, so it's going to be start at 0, go all the way around. There's 180 plus another 30, that's 210 degrees. All the way around to 180, all the way around to 360, subtract 30 is 330 degrees. Okay. Last one, same thing. Okay, let's take the minus 1 on root 2 across the other side. So I get cos theta equals 1 on root 2. So whereabouts is cosine positive? It's there and there. Cos of what angle? Theta is 45 degrees. So I start at 0. So my angles are 45 degrees. Now obviously negative 45 degrees would also be 1, but it's not in the domain that we've been given, 0 to 360. So 45, 360 minus 45, which is equal to 45 degrees and 315 degrees. All right, this last one here is sort of trying to make use of the complementary relationship. Now, cos x, so the key is here to try and get cos x and sine to be the same angle, so the same ratio. So I've got to turn cos x into sine x. So from up here, there's our relationships between turning cos into sine. So I can, if I want, looking at the quadrant we're in, so if I extend this diagram out here, okay, see this pi on 2 plus theta? Well, that could be 3 pi on 2 minus theta. So I could, so cos x, so let's have a look at over here. There's, how can I get a cos? So I want to replace this cos x with a sine something, okay? So sine pi on 2 plus theta is the same as cos theta. And in the same way, sine of 3 pi on 2 minus theta will also equal cos theta, okay? And so then I can replace that term there with sine of 3 pi on 2 minus theta, and that's going to be equal to negative sine pi on 6. So if we think about this value here, that value there is in the third quadrant where sine is negative. So this is a negative value. This is a negative value. So for these two things to be equal, therefore 3 pi on 2 minus theta has to equal pi on 6. So theta is equal to, let's turn 3 pi on 2 into 9 pi on 6 minus pi on 6, which is equal to 8 on 6, which is 4 pi on 3. So if we want to check that, the angle is in the domain that I want, so that's good. What is cos of 4 pi on 3 is the same as negative cos pi on 3, which is negative a half. And if I check the right-hand side here, negative sine pi on 6 is also negative a half. So, boys, just look, have a look. There's not too many questions like this one here. And again, I think these are questions really unique to the textbook. Never ever seen them on an exam 1 or exam 2 for that matter. So look, we covered this, just knowing that it's something you should be aware of, but yeah, that's not one of the key areas that I'd be focusing on. Okay.